Welcome to this episode of the Structural Engineering Channel, a podcast focused on helping structural engineering professionals stay up to date on technical trends in the field and to help them succeed in their careers and lives.
In this episode, we are talking to Maria Eugenia Chumbita, who is the Vice President of Engineering at CoreBrace. We're going to be talking about the use of buckling restrained braces in structural engineering and what her career path was like. I'm your co-host, Matt Picardle.
And I'm your co-host, Kara Green. Now let's jump into our conversation of the week with Maria Eugenia. Maria, welcome to the show. Now, in your own words, can you please tell our listeners a little bit more about your career journey and what it is you do on a daily basis at CoreBrace?
Thank you for having me very much, Matthew and Kara. Yes, of course. I am currently the Vice President of Engineering at CoreBrace. We're a manufacturer of a specialty structural element that is called buckling restrained braces. They are one of the systems currently available to improve seismic performance of structures. Our engineering team here wears a lot of hats. Our engineers do a lot. They work in production engineering. They also get to work in R&D, research and development. They do presentations. They work on our educational and marketing initiatives. And I am involved in all of that. And particularly, I am in charge of all of our contractual work, which means the engineering that we produce once we are awarded a job. And that once it is approved, it will be the input for the shop to build the braces specifically for that project. BRBs, that's the short for buckling restrained braces and how they are commonly known. They are not a catalog type of system, so we will build them specifically for each project. So that's why we have to produce engineering every time. And yeah, we do that on a daily basis, and I oversee that kind of work. I'm also part of our executive team here, so we set the general business direction and make the decisions that pertain the company as a whole. Regarding my journey, I am born and raised in Argentina. So I did my undergraduate there in civil engineering. I worked for a couple of years in an engineering and construction firm in Buenos Aires as a design engineer for their steel structures department. And at the same time, I worked part-time as a professor of structural analysis in my university. So that's kind of how I got introduced to some opportunities for study abroad. And I applied to one, I got it. Yeah, that wasn't planned, that's a story for another day. But I came in 2008 to the States for my graduate studies, after which I went on working at a consulting firm up in Oregon as a structural engineer. And in 2011, I joined CoreBrace. I've been with them for 10 years now.
That's awesome. Could you go into more of the buckling restrained braces for our listeners that aren't too familiar with it? Can you explain to them what BRB braces are and how they work?
Yeah, sure. So BRBs are a special kind of steel brace. They are in the end a steel brace. And they are built in such a way that the global buckling of the brace is prevented. It's one piece, the final product is one piece that is composed of different elements, if you will, that each one has a function so that they can work the way that we intend them to work. So there's a steel core, a steel plate, A36 steel, that is the one that resists the tension and compression loads as a brace does. And it goes inside a steel tube that is filled with concrete. But they are built in such a way that the concrete and the steel core, that's what we call the plate that goes inside, they are decoupled. There's an air gap in between them. So they don't act together as a composite section. The one that is resisting the load is the interior plate, And the assembly of the casing, the steel tube, and the concrete inside is there essentially to restrain that blade. So it's there to catch it, if you will, when it wants to buckle in compression. So what that does is that it allows the brace itself to be able to reach yield in both directions. And that yielding of the steel is the energy dissipation mechanism that we use to dissipate the seismic energy that the ground may be imparting to the structure in a very tactile way. I know that we're doing a podcast, and so this may get lost in there, but this is what they look like. I brought a little model here. So this is where it connects to the structure. There's a gasket plate here, a gasket plate here, and this is what they look like.
Yeah, for our listeners that are listening via podcast, it's, I guess you can imagine a brace, a square or a circular brace, but it's filled with concrete, and inside that concrete there's that piece of yielding steel, if I'm getting that right. Yeah, just for a visual.
I know it's hard to describe it. We usually have some kind of like graph or model or something to kind of show it, and when you're looking at it, it's pretty easy to understand. Describing it in words is a little bit harder. So if someone is watching the video, they would probably have a better time with that. So yeah, these braces became very popular in seismic design and in construction for a number of reasons. I think one of them is that they are codified. They are listed in the code. If you go to ASC 7, they are one of the systems listed there as available force resistant, seismic force resistant systems. And then they are pretty well described in the seismic provisions, AISC 341. They have a section there with parameters and a lot of information. There's also the commentary. There are some design examples in the manual part of the book. And there's also plenty of information that is published by the manufacturers. So I feel like there are a lot of tools and resources that can make design fairly straightforward to implement. You don't have to really invent anything. There's a lot of information out there. And they are also very cost effective. In the end, buckling restrained brace frame, which is the system that the braces are part of, in the end, they are a brace frame. And so, they allow for a very efficient use of material, and they are very ductile. So the parameters for design are pretty favorable. And also, I think that because per code, everything that is designed with BRBs has to use design parameters that are obtained from testing, which is full-scale testing. That gives a sense of kind of like predictability, and people feel pretty good about what to expect regarding the performance if they haven't tested so extensively. So it seems to be a pretty predictable behavior.
Since I've worked with buckling restrained braces before, and yeah, I think they basically have a really, for the engineers out there, they have a really large R factor. Basically, your base shear is going to go down, and that's why we like to use them. And like Maria was saying too, they're essentially they're brace frames, but the buckling, which is usually found in, if you ever do a typical brace frame, they tend to fail in buckling. But with CoreBrace or buckling restrained brace frame, that's like the whole point. It's strong in tension and compression, so that kind of makes up for a brace frame's weakness. And I think that's what's that was my experience with them. We like getting those base shears down from a design perspective.
Yeah, I always tell people that whoever studies or reads anything related to structural design, or even leans into some kind of like slender element, you learn pretty quickly that buckling and instability are not your friends. They are very undesirable, modes of failure. And by I wouldn't say getting rid of them, but by getting them out of the equation, we get a very much improved behavior in general.
So You talked a little bit about how this is a highly coded application. There's a lot of design guidance. There's no ambiguity in regards to, buckling restrained braces. Can you talk a little bit about what some of the requirements are for designing buckling restrained braces, and maybe talk about any of the latest developments, because code never seems to stay the same and it always changes?
Yeah, well, maybe I shouldn't say that there's no ambiguity. There's always some kind of like novel application or specific application that we will have to look into because it doesn't quite fit into the data that we have right now as to what would be more of a representative kind of job. And the way the code is written right now, anything that we want to do, we kind of have to test for in order to support the analytical procedures or the parameters that we are giving the design engineers. In terms of requirements, well, I would say BRBs in general do make a really good solution for a lot of structures in seismic areas. I think that they may be one of the solutions, depending on the project specifics. Some others may be better suited for a certain case. The one thing that typically does control, if it is a consideration, are aesthetic requirements or architectural requirements. We have been able to work around a certain architectural concept and put them in location, put the braces in locations, whether they will either work with the environment they're in or they will be concealed. But sometimes if one of the requirements, is a full open space and the designers want the flexibility of an open plan, then that may be the one thing that will require a different solution. In terms of research and development and things that we develop, we do that all the time, mostly because it's required to have that experimental part of the process. And so what we do is we try to go with the industry and satisfy the demands that we're seeing from our market and from our users. I would say lately, in the last few years, we have seen a big push in terms of like sustainability and reliability. And there were a lot of questions that came up after recent events in the sense of, okay, let's say that there's an earthquake and the building stays put and your braces were great. How do I know, what state they're in? And, we had to kind of like figure out how to address that because it was coming out from more and more users. And so one of our latest developments is a little device that we can install in the braces to essentially record a history of displacement. And we also developed a testing program, kind of like separately but related to it, to come up with what would be fatigue curves for BRBs, if you would. So with those two things, what we're trying to do is help in the post-event evaluation. So you can go and download the history of displacement for a certain brace that you're monitoring, and then process that data and use the curves that we developed to see essentially how much of your brace you have used, so you can make a decision. And, you can see if there's remaining capacity, if there is the potential of considering a replacement or things like that. We think that this is something that is coming up now and it wasn't available before. And this is what we were putting our energy lately in trying to solve.
Yeah, that's very cool. I know it's a lot of the times you don't really get to see what's inside it because it's covered by a brace, but with the research methods, you can kind of get a real-time deformation curve or how the brace is performing and what condition it's in. Like, is it in good condition? Is it in bad condition? Because a lot of it's covered up. So it's pretty cool to hear that there's a lot of research going on with that. Mm-hmm. Going back to kind of the design process, you mentioned that it is different. Unlike typical braces, it's a proprietary product, or you need the manufacturer, the designers to aid in designing these core braces, these buckling restrained braces. Can you go over the, I guess, the process and how it's different from typical structural design, and what that whole process is from design all the way to construction, working with buckling restrained braces?
Yes, yes. So it can be a little bit different, but in a good way. So technically, because they are in the code, and the code give you some design values, someone could design a BRBF without any input from the manufacturer or from a manufacturer. However, we have found over the years that there are a lot of advantages in bringing the manufacturer early on into the project, from the feasibility analysis into like kind of a design phase. We, in the great majority of projects that we do, we coordinate with the designers while they are analyzing their structure. And this coordination can go from giving them more customized design parameters for the braces that they will be using, to sometimes giving recommendations on the type of connection that would be more economical or more adequate for the specifics of this job. We sometimes give some input on details. We help them put together information that will go into their contract documents. We submit some supporting calculations, or give them, a template for a specification section, whatever it is that they need while they're working on designing the structure and putting together their contract documents. And this is particularly useful because as a designer, you want to specify a solution that is attainable. And if we can find or detect anything that would need some extra coordination up front, then that streamlines the process a lot along the way. Because once the project is out for bid and it gets awarded, well, times are a lot shorter. And so once you get all of those things out of the way, then the process from there on flows a lot better. After the project is out for bid, we will put together a proposal and typically submit it through steel fabricators. They will carry it as part of their proposal for the steel package. And once it is awarded, if we were the successful bidder, then we get kind of like into production mode. So we will create the engineering specific for this job, regardless of whether we had coordinated up front or not. And that engineering package typically, in most cases, in kind of like a deferred submittal type of document, we will submit that to the design team so that they can verify that we are in fact meeting all of the requirements and the assumptions that they made through the design of the structure. And at the same time, we work with the people that are detailing the steel so that we make sure that we're on the same page on geometry and that they are incorporating our information correctly in their shop drawings, and all of that we can do to minimize any potential conflicts in the field later on. Once we receive approval from the design team, and we also coordinated the detailing part with the steel detailers, then we go into fabrication. So we will procure the material and we will produce our own shop drawings through our detailing process that will go into our shop to fabricate the braces. In the meantime, our project managers will coordinate with the client the erection sequence and the order in which the loads have to be shipped so that they can be delivered in the job site as they are needed. And then we finally deliver, typically very much on time, to the job site. And we're involved also afterwards, through the construction administration phase, kind of, if there are any field fixes or field conditions, if the inspectors bring something up, we do field visits too, to see how they look, and before and after they are installed. We really remain with the project until it's kind of like finalized.
Thanks for that. It's, I guess, as a summary for that, it's basically you're working with all the teams that are involved in that design. You're helping out the design engineers from the very beginning, from a feasibility aspect, and then helping them come up with the best solution to work with BRB frames, and also basically providing the calcs for the BRB frames and some of the detailing aspects of it, and then also working with the steel manufacturer and all the way to construction too. So yeah, that's a little bit different from your typical design, at least from my perspective, is that at least in Southern California, if you're doing a non-buckling restrained brace frame, basically the design engineer does all of that, which may or may not be economical. So definitely getting that input from, from the manufacturers that are doing the BRB frames, yeah, definitely helps out.
Yeah, that is a big part of what we do. And I feel like after working for so many years with engineers, there are a lot of things that are a little bit out of the way now. I mean, they know how we work. They know that we will tell them if we don't think that the solution is the best, or we don't charge. This is all a complimentary kind of like process. And even if we are brought early on, that doesn't mean that in the end you're going to have to have BRBs or you're going to have CoreBrace in there. Some people want to keep it really neutral, and I completely understand that. So the nice thing about this system is that you can make it pretty neutral. You don't have to name any names. I mean, if you want to name us, I'm not going to be offended, but you don't have to put like specifically CoreBrace information in there. You can just leave it as a buckling restrained brace frame, and anyone that can make one and that can prove that they can meet your requirements can supply them.
So Maria, just to kind of pivot a little bit, because you gave us a bit of your background, and honestly, it sounds really impressive. It looks like you took a lot of opportunities that got you to where you are, and you appear to be extremely successful. So can you talk a little bit about personal development and, the design world? We like to think, in design, everyone works in their own little box, and, we're all keyboard warriors. We all focus just strictly on the numbers. But can you talk a little bit about human connection in design and, how important you deem those two particular aspects to be?
I think this is so important, and I love to have this conversation. I will take any opportunity to say it because I personally went through engineering school. I have a very technically oriented mind. So I really enjoyed engineering school, and even practicing as a junior engineer, I felt like I had good skills to do an adequate engineering job. But I have to say, me personally, when I started getting into more of leadership roles, I noticed that I was lacking a little bit on other type of skills. So I thought, it's a little bit intimidating, but I think that I have the knowledge, I have experience to kind of like lead a technical team. And when I first started, it felt good. I was like, yeah, I know what I have to know, and if we don't know it, we have enough collective knowledge in here that we can figure things out. But I remember, like, not long after I became chief engineer here, someone came to my office and they requested a minute, and I was like, sure. So they closed the door, and I was like, what's going on? And they proceeded to talk about a matter of more of a personal nature, and this person was pretty affected by it. So I was sitting there trying to listen attentively and trying to apply, the tried and true method, understand the problem so we can brainstorm solutions and evaluate them and pick the best one. And my mind was going in loops. I was like, no, I don't know what to do with it. I don't know what to do here. And I think that's when I remember that because I started like grasping the concept of leadership from a different perspective. And as much as I really wanted someone, to come in with an RFI or something, so I could bounce back into my comfort zone, that didn't happen, and we had to work through this, and we did. But after that was over, I thought I had to do something in here. So I made sure that I got some training in things that so far, I don't know that I hadn't felt like I needed them, but somehow for me were less important, and so, or they were not a priority. So I took, some courses in communication and organizational dynamics, and I started thinking, you know what, I actually always had like another part of my brain that I satisfy in different ways. I'm an artist and I have that kind of thing, but I kept them very separately. And I thought it kind of like came from a well-intentioned, but kind of like all advice, keep things professional, don't cross any boundaries, know your science, you can't go wrong with that. And it's true, it will work. But I was like, this is kind of limiting, and why have I been like kind of neglecting this part? So that took, a different kind of effort, at least on my side. And that's why I want to always make people aware of this, because once I was like, we're all people, and if I want to connect with someone and know more about them and know what drives them, what makes their day, how to better communicate with them, how to have better rapport, not only I think that performance-wise things improve because it flows so much better, but it also makes, at least it made my work so much more enjoyable, And I cannot claim that I am familiar with current engineering programs or things like that, but me personally, I got training abroad and in here, and I kind of wish that there was more in there about the soft skills and even, sales skills, trying to approach that from a perspective of service, of having a solution that can help, not as something embarrassing or demeaning because you're trying to solve something. That's kind of like what I had in mind. I don't know, for whatever reason. So I think that even though you learn that on the job, is something very important to keep in mind. Just because we are, in general, engineers are very technically minded and we like science and we like numbers, that's great. And I will be the first one to want to keep up with all the new technical things out there. But I believe that approaching it from more integral perspective makes for a very rewarding day-to-day activity.
I actually, I adore your response, because it's something that, it's something that I have identified myself, and, not to leave you out, Matt, but I think it's something like women, especially in engineering, like learning our boundaries and where our boundaries can be pushed out to be more inclusive. I was actually just talking to a really good friend of mine, because right now, obviously I have a lot of male coworkers, and I treat them, I've made the objective choice to treat them the same as my female coworkers, like the same language. And it's very interesting how much they relax. Like, right? It's and not in like a weird like way, but it's more of a friendlier environment. Like, they're more willing to tell me about their children, or, the fact that I have like 3 coworkers where their wives are pregnant, and they're like, right. Yeah, she's making me go get ice cream, and it's all of these crazy things. They talk about the excitement, but it's when you kind of relax, get out of that technical aspect, which is of course incredibly important, especially in our careers. It's nice to see exactly what you said, the rapport that comes out of like lowering those boundaries and not necessarily like focusing only on the technical. Like, I really care about my coworkers, and it's so nice that, I can tell, they're more comfortable to come to me with issues. Or I have some coworkers, they want to get my feedback first before they go to someone, higher up in the company, because they're like, can I just bend your ear? Does this sound right? Can I test this on you first? Yeah. And it's really nice that you brought that up, that how important those extra skills are, and how it, I hate to say the word relaxes, but it like de-stresses the environment, the working environment, when you kind of facilitate those connections.
I agree, very much so.
Yeah, it's you're talking about the training that we do, and it's at school. Yeah, definitely mostly technical, but as all the engineers find out, you're gonna have to go talk to people. You're gonna have to work on a team, and you're gonna have to communicate, and maybe eventually end up in a leadership position like you, Maria. And I think they all have to learn that lesson of, sometimes you just have to listen, and that's how you build trust with your team, because you can't do everything alone. And sometimes you don't need an answer. Sometimes you just need to listen and see what they're going through, and maybe have some empathy on maybe how you can help, or sometimes we're just going through a tough time, or what motivates them in the end. So yeah, definitely a core lesson there. Did you have any other maybe lessons learned that, as in your career progress, that you can think of, whether it's career or maybe out in the field or coordination? Do you have any other big lessons learned?
Well, I think that when you ask about lessons learned, or when people ask about lessons learned, my brain at least immediately goes into, oh yeah, I remember that one time when we had this play that didn't fit. But if you're talking in a more general way, I think truly, because I have sat down and thought long and hard about this, I think that the most important lesson, it really comes down to communication. I think that the biggest things that I have learned, of course, sometimes the more painful ones are the ones that you learn from the most, but they all come down to that. It's like at some point, there was not clarity in the communication, or there was a misunderstanding, or there was something that didn't come across the way it should have, and then there were assumptions, and it kind of like grew from there. So I think that most of the lessons are related to that. The other thing that I would say I have learned, me personally, and for anyone that can relate to my kind of personality, I think that engineers are very achievement oriented. I'm very results oriented, and I am no exception at all. But I think that it's really important, especially when it's a collaborative effort, when you have a team, to really celebrate the small victories. When something goes well, you gotta give it maybe not the exact same importance as when something doesn't go well, but you gotta give it importance. You have to highlight that. You have to give people kudos. You have to say, this is something that we did right. Let's learn from this too, to do it again, as much as we learn from things that we don't want to ever do again. And I would say that another one is kind of like along the lines of what we were talking about, is we learn to select our people carefully and get to know them really well. And I think that has a tremendous impact on what your team can accomplish. When you make sure that you have a good fit, in our case, we train our engineers in something that is very specific. So it takes a while for someone, since they join us, to become fully productive. And once we put all that work and effort in there, and we consider them part of the team, we want them to stay. And we have done, I think, a really good job at that. I'm very proud of the team that we have here. And I noticed that by kind of like continuing to make that effort to bring in people that really fit in and that are happy here, our performance has had a very good result out of that.
That's great. And so you touched on one of the key lessons learned, which is communication, which is something that is recurring on our podcast, is how important communication is. But one thing I wanted to end off with here is, we have a lot of young engineering students that do listen to this podcast, and you've had a very successful career, which it sounds as though, you're young, so you still have a long career left, which means you have many opportunities to succeed even further. But is there any advice that you could give young engineering students considering a career like yours?
Yeah, actually, I was pleasantly surprised. I think that when I went into engineering, I pictured myself going into the more traditional roles, in consulting or similar, and that excites me, and I like that. But I was pleasantly surprised down the line that there are so many things that you can do with this career. There are so many aspects to it that I want to say that whoever is starting or is in an early stage in their career take a minute to see all of those options and see if there is something that they want to explore, especially early on. But I guess you can do it at any point, because like in my case, I always enjoy design, and I did like my work in consulting. But when the opportunity presented itself to do something different, to work in this more non-traditional role that I have now, but back then it was as a design engineer, kind of like in a different way. I decided to try it out, and the first thing that came to mind is, I don't think I ever thought about doing something like this when I was studying, especially because there's a lot of like more of a commercial component to it, and sales and presentations and things that when I started doing, I was like, oh, I really like this. I really enjoy talking to people. I really enjoy explaining something or brainstorming solutions in a different way. And it was something that for some reason was not completely in my radar. So that would be my main advice, to go and find something or see what's out there, and maybe be willing to consider something different. And see if you can find something that really sticks to you, because for me, that can lead you to a really rewarding career, something that you enjoy. We're meant to enjoy what we do too. And I think that that's probably a way to try to find that.
Thanks for that, Maria. I like the advice. I know it's like you're saying, the traditional route is to go in design consulting, but there's from talking to all these different engineers and people on the podcast, there's so many different career options out there that you can do with structural engineering. And it's great to see you, going for that and making sure that it's possible. And yeah, there's a lot of great things that you can do. So even if this traditional path isn't right, there's a lot of different options for students out there that may have different skills or may like different things, but still want to use structural engineering. So thanks so much, Maria. Thanks for coming on.
Yes, thank you so much.
Yeah, thank you, guys.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, or any questions you may have. To leave them, please visit structuralengineeringchannel.com. There you will find a summary of the key points discussed in today's episode, which is episode number 63, as well as any links to any of the resources, websites, or books mentioned during this episode. Don't forget to subscribe on Apple Podcasts or wherever you listen to your podcasts. Until next time, we wish you the best in all of your structural engineering endeavors.